Since the dawn of time, our drive for a better life now draws the map of our future. And Sofia Tech Park is the home of innovation. Business, science, and education feel at home. The laboratory complex of the park is the cutting edge of progress. Total of 11 high-tech laboratory units, led by luminaries of Bulgarian science. Innovation is the focus of all the startup companies in the business incubator. Sofia Tech Park is home to dozens of young Bulgarian enterprises with a high-tech profile. Sofia Tech Park is the home of innovation.
Hello ladies and gentlemen, I'm Kristiyan from Professional Association of Robotics and Automation, and I'm together with Ionko Chuklev, co-founder of Para. Hey Ionko,
how are Chris. You? So far so good.
According to the media company Recursive, Croatian robotics company Gideon Brothers has attracted 31 million Series A funding recently. Another company like Boston Dynamics closed a huge deal of more than $1 billion with Hyundai. Such news actually got covered in media when it comes to robotics and automation, but I'm sure that you follow another, as a media expert and robotics expert, you follow the topics of robotics. May you share another news that spin in your mind?
Mm-hmm. So we have a lot of ecosystems around the world, some around companies like ABB, some around the companies, the likes of Hyundai, the likes of Boston Dynamics. So we have like small ecosystems in countries such as Bulgaria, Croatia, and we have obviously large ecosystems at the likes of the US. Today, we're with our members and partners of Reciprocity ROI in order to discuss how do we create an ecosystem revolving around AI and robotics.
Hello, ladies and gentlemen. Can you hear us?
Yep. That's good.
So, a few words about Reciprocity. Their motto is solving with innovation to improve people's lives and advance global society forward for the greater good. Am I right, guys?
Absolutely.
Hey, John. May you share a bit more about Reciprocity and the connection of Reciprocity with robotics and AI?
Well, Reciprocity is focused on developing new concepts, new visions, and particularly around AI and robotics. So we do a variety of services and a variety of programs to develop new ideas, new product concepts, and new relationships, with groups like Para around the world. So we're very committed to the AI plus robotics area. And we have several people today from our network that we're going to present briefly, each of them are going to present briefly about their perspective, and then, we'll have a roundtable and answer just, a few questions.
Excellent. Can you give a brief of each of your team members who's joining us today, John?
Well, I thought when they come on, maybe they'll introduce themselves. So if that's okay, if that works.
Yeah.
Okay, great. So if you don't mind, we'll start with Erin. She's going to give us some feeling for her perspective on the future of robotics, what the current issues in the future of robotics. So Erin, you want to introduce yourself and then?
Certainly. Thank you. So grateful to be here. My name is Erin Bishop. My career in the past, Erin Bishop Rapaki. So I've given a number of talks and podcasts and conference talks over the past 10 years for robotics and startups. I worked at a number of robotic startups in Silicon Valley for the past 10 years, and I was in the Boston robotics community prior to that while I was in college at Northeastern University. Some companies you might have heard of. I was at Industrial Perception when we were bought by Google in 2013. I was the product manager for what was then called the Adept Lynx mobile robot, now the Omron LD. That was 2011. So my team was one of the first people running small mobile robots around the warehousing shows 10 years ago. And what we saw was that robotic technology would soon be able to address variable environments. And you think about it as a continuum in terms of the future of robotics. For the past 40 years, robotics have been working on welding cells in manufacturing or electronics assembly. And those are very fixed tasks. A robot is doing one thing over and over again for years. And that commanded an ROI, a valuable ROI where someone would program that robot for a few weeks or a few months for installation, then that robot would run itself for years, doing more or less the same task. What's happening is that robot technology, the ability to do real-time grasping, which is with welding robots before, you have your fixed base, you know where your base is, you can program that to be a repetitive motion. Now we need 3D cameras, we need AI, we need computer vision in order to choose an infinite number of grasp points on different types of products like packaging food, warehouse bin picking, all of these unloading trucks, unloading boxes, palletizing, depalletizing. And that takes completely new technology. And that's the exciting thing about robotics now is this new technology can do real-time grasping and real-time motion control and then do more tasks. And why this is important is actually the abundance of demand for e-commerce and goods and services. What we saw 10 years ago was the e-commerce boom was putting a strain on warehouse labor. If you think about the math, when I spent 20 minutes to drive to my car to go to Walgreens, I'm actually doing, or a pharmacy, I am doing my own free labor to pick the item. Now, all of that time and all of that labor is transferred to the e-commerce warehouse. And that's why there's such more demand for robotics in warehousing and also more demand for robotics in manufacturing. So in terms of the future, the need for robotics as tools for people to increase their productivity on construction, warehousing, manufacturing, it's a continuum. The technology is getting there. I also angel invest in robotics companies. And what I really look for when I'm doing angel investments are robot companies that have intellectual property around a deep tech component of their technology stack. Are they leveraging a new sensor? Are they leveraging a new controller? Do they invent something? And robotics right now, there is a glass ceiling of performance. There are robots that'll perform to a certain point, but it might not be that reliable for picking small items out of a bin. It might not be that reliable as a forklift yet. And in order to break through the barrier in performance to make these robotic assets valuable and worth the investment, there's still a lot of deep tech problems that have yet to be resolved. And sensors, controls, AI, and simulation. And a lot of it's about the speed of controls as well. So edge is very important because we can't, and Wi-Fi connections, we can't exactly trust the cloud. So we've learned over the past 10 years. I think I'll stop there. There's a lot of opportunity to apply deep tech research to improve the performance of robotics. And the world is demanding more robotic tools in the future, and that won't stop. So that's where I'll sit right now, but that's kind of where my thoughts are today.
And we would say we demand to break the glass ceiling of robotic companies. So I would agree with you completely on that one, Aaron.
Mm-hmm.
Great. Thanks very much. So similar, I think we've asked Phil Boucher here, and he's going to be talking about some of those issues in AI, where that's going.
Hi, I'm Phil Boucher, the CTO and founder of Fornox Incorporated. We specialize in memory management tool and speed up tools to speed up AI algorithms. So basically, that's what we're focusing on. related to the subject today, I would like to first, since I'm a technical person, I would like to first talk about technicalities here. To have a general overview of artificial intelligence, we hear a lot about deep learning and machine learning and things like that. This is just a subsection of artificial narrow intelligence. And eventually we're working on general intelligence and super intelligence and collective intelligence and so on. But just to give an idea that deep learning is really just tiny subsection of the narrow intelligence. So with having said that, I would like to move on to the predictions. These are the predictions of artificial intelligence as taken by IDC. By 2022, over 60% of customer-focused AI decisioning system in finance, healthcare, government, and other, and other regulated sector will include provision to explain the analysis and decisions. By 2023, rather than continue to move away from the voice channel, over 30% of organizations have added AI capabilities to their inbound call handling environment. By 2024, 50% of knowledge workers will regularly interact with their own AI-enhanced robot assistants, which will help identify, prioritize tasks, collect information, and automate repetitive work. By 2025, the number of data analysts and scientists to adopt auto machine learning for their end-to-end machine learning pipeline from data preparation to model deployment will triple. By 2024, AI ops will become the new normal for IT operations, with at least 50% of large enterprises adoptions AI ops solution for automating major IT system and service management processes. By 2026, this one is interesting, 20% of all AI solutions will be closer to AGI, leveraging neuro-symbolic techniques that combine deep learning with symbolic methods to create robust human-like decision-making. So this is the neuro-symbolic technique is the link between deep learning and AGI. AGI is a representation of human capabilities. By 2022, at least 65% of G2000 companies will leverage AI tools such as natural language processing, machine learning, and deep learning business-wide to enable 60% of use case across areas such as customer experience, security, facilities, and procurement. By 2024, over 30% of G2000 companies will run AI workload distributed more evenly from core to edge to cloud, and will be managed by AI software platform providers, making these infrastructure invisible. By 2023, 60% of enterprises will run varying levels analytics and AI models at the edge, and 30% of those edge AI applications will be accelerated to heterogeneous accelerators. By 2023, finally, 80% of G2000 enterprises will invest in internal learning platform and third-party training services to recapture freed employee capacity and address new skills needs driven by AI adoption. So, yeah, so that gives a general overview of you know, what to expect in the years to come. And but I wanted to clarify first the big idea of artificial intelligence as a whole, because you know, there's a lot to do, and obviously you know, it's not just deep learning, it's more than that.
So a big future and a lot to do. Yeah, absolutely. Yeah, that's great. Thanks.
Thanks for your for this information. By your opinion, which incentives is more effective for building an ecosystem around robotics and AI? Investing in large-scale projects or micro-level support programs for research center startups and local authorities? Which are the building blocks of AI and robotics?
Yeah, I think we're going to address that. I think Mitch is going to talk about that. I'm going to talk about that some as well. I think that the part of our context for it is a specific kind of a domain focus, which, you know, I think might be related to that. I think we're particularly interested in healthcare right now, and healthcare applications, and healthcare applications have a certain complexity to them in terms of the ecosystem that needs to support that, and that kind of changes the game a bit in terms of what you know, of what kind of would be useful. So in a less complex area, you know, kind of startups can thrive. They can have their own products. You know, they can go to the market by themselves. In the medical healthcare area, maybe not so much. So maybe they need to have different kinds of incentives or programs. I think Abhishek was going to talk a little bit about AI and healthcare, you know, and sort of what are the complexities about that, and how does that inform the question that Kristiyan just asked?
Yes, well, I'll introduce myself first. I'm Abhishek. I'm the founder of iDream. We basically are vertically disrupting the entire optic industry. And a bit of it contains robotics, a bit of it contains IoT, a bit of it contains AI. But I'm a statistician at heart, so I don't really believe in AI as per se in the current stage. I believe in rule-based systems, which is organizing and cleaning the mess, which is our healthcare system. If, as a general introduction for what healthcare is, it's empirical evidence-based learning, which basically means there is a lot of information which is observed, and that information is then put into input and output-based systems, which our doctors, our clinicians, and all of our research aspects of it use. And this is all data, because information at the heart is data. And where healthcare is evolving is we had this disjointed data, both in manufacturing, in robotics, also in our hospitals, in our information systems where doctors had to read research papers and so on. So the general problem which faces the healthcare is how do we start organizing this? Because if we organize one part of it, it still remains disjointed, because then there's all of these other aspects where it is interdependent to make a decision, or what we call is a diagnosis. And this instant diagnosis and the requirements to more and more map predictive diagnosis is ever increasing. And the only solution to that is kind of organizing that information in a way which works. And this is where the future of healthcare is going towards, basically creating a rule-based centralized control system, which is also distributed at the same time, which can contact and communicate according to these rules, maybe with some form of human interaction in the middle, and effectively provide diagnosis support and any of the management which requires, whether it's in the form of patient prescription and so on. As a use case, I'll tell you what we are doing. We're basically started with trying to see how can we make eye tests better, how can you make the eyeglasses process better, and we just went to the first principles. It's basic physics. So we used we created a smartphone-based application which can basically detect under 60 seconds your eye prescription accurately. And that's one of the deep technologies I guess Aaron was talking about. And then why that's a deep technology is because then we connected right to the manufacturing chain. Because then we looked at material science and we realized, why are eyeglasses so expensive when the material cost is around $1? And we realized that 3D printing can solve that issue. Post-processing is always going to be an issue, as robotic in healthcare, when you're integrating this kind of concept where, okay, you have diagnosis and then now you have to order something which is akin to a medical device. You have to ensure that the process is smooth. One of the biggest limitation of robotic is I don't believe it's the hardware, it's the software aspect, which is where I come in. So we are trying to kind of approach it from the software, how we can add more precision through just simple, repetitive learning, repetitive rules, which we add more and more layers of through trial and error and Six Sigma process, if anyone is familiar with that in manufacturing. And then we directly connect it to our application. And what we end up with, which we are currently creating, is a system which is the same size as your dining table, can fit anywhere, and can print out and then produce through robotic arm lifting and the post-processing process, which usually follows 3D printing and the assembly, something which is akin to prescription glasses. And then it is directly connected to your diagnosis, which is your eye test, which optometrists are responsible for. And then we go into the EHR systems of the hospitals, which are the biggest mess if anyone has ever worked in hospitals. Each hospital has their own system. Some don't even have a system. And most of them are still following some form of paper trails. So trying to convince them, the ophthalmologist who is just used to talking directly with the patient, that, hey, you should use this software, is kind of an impossibility. So you have to kind of add you have to kind of take a step back, let the humans do their thing, and kind of add the assistive element to it too, which is kind of an assistive EHR, where it just provides, let's say, referrals more accurately, which is the biggest pain point for ophthalmologists right now, because if they get the wrong referrals, then that's a problem. So this is an example of like how each information packets throughout the whole vertical process could be solved quite simply if you start approaching the problem step by step. And that's where healthcare is heading. It's heading towards a vertical integration in a distributed nature, where the whole end-to-end process is integrated and the care is given in the patient's hand. A wearable care, instantaneous supply, instantaneous communication. This is only possible through creating smart rules and statistical models which can predict which relevant use case it is. And this is exactly where we are heading in terms of robotics, in terms of AI. It's just kind of cleaning up this messy room we have made, which is the internet, the boom, all this information not being used, putting it together in a form where we can use it in more precise manners. So that's about what we are doing.
Thank you, Abhishek. I think that's an example of where if you defined your ecosystem too narrowly, right, just AI and robotics, you're missing a huge set of opportunities, that really, are about integrating a much wider view, of both the technology, the applications, and the requirements. Mitch, you want to talk about because you're definitely wanted to address some of these issues about what incentives or what issues might be relevant in that sort of ecosystem enhancement or ecosystem support area. Let me see if I can.
Everyone so far has touched at least slightly on the things that I want to discuss, which is a good segue into me and my background. I'm currently the global R&D board advisor for Reciprocity ROI. My background basically includes working with developing technology accelerators and regional economic development and ecosystem development agencies around the world, ranging from Asia to Europe to the United States, to help them more efficiently get going and do a better job of getting into the marketplace and getting the most bang from their ROI dollars. I think as a brief intro to what I'm going to present, 3 terms I think you should keep in mind: focus, alignment, and win-win. And I'll explain each of these in more detail as we go along. One of the things that we tend to forget when we are developing new technologies, particularly new technologies that are susceptible to a lot of hype. And over the years, certainly robotics and AI, amongst a very long list of other technologies, attract a lot of attention. A lot of investment dollars go into the development of these technologies, both at the government level and at the private level and at the VC level. But the effect that that investment has on the marketplace tends to almost always be underwhelming. And the reason why it's underwhelming is that technology without a specific applications or use cases is basically useless. It's an exercise in generating dissertations and publications in academic journals, but you need to put together the pieces and focus on applications for which there is an unmet customer need. And that may include technologies that have nothing to do, as John mentioned, with robotics and AI. So if you're looking at private investment, as we have here, it's important for local private investment sources to support joint and cooperative R&D that helps put these pieces together, to support startups that have a good view of developing customer needs and market sense, and if the startups are weak in that area, to help them to provide the input that will allow them to have a greater market focus, and to work with startups to develop near-term market entry strategies. One thing that we see all the time, that I see all the time, is startups get so focused on their ultimate end goal of basically creating an earth-shattering or world-shattering widget or service or product, that they forget that even with an imperfect technology, there may be early market entry opportunities, either in terms of early generation markets and services, or in fact, out-licensing opportunities. So again here, all of these focus in the general area of alignment, focus, to overuse that term, and creating a win-win situation for all of the participants or potential participants in the ecosystem. Next slide. In terms of government investment, governments are not immune from the swan song of investing in technologies based a lot on hype. So the governments themselves need to have more of a market focus, insist on some market relevance in the grants that they fund. I think at an early stage, government should really are more effective in focusing on a variation on the 80-20 rule. In this case, early on, 80% of government funding should go into funding basic or very early stage pre-competitive research, with 20% going on more commercial, towards more commercial development. Then over the course of about 10 years or so, gradually reverse the proportions. They should also do a lot to support interdisciplinary forums and organizations that promote academic and commercial cooperation. You really want to start generating cooperative research and development agreements at an early stage. And in terms of policies, what has been successful not only in the United States, but where legally feasible in other parts of the world, are things like R&D tax credit, SBIR-like programs where you foster cooperation between academic institutions and commercially focused institutions, and Bayh-Dole-like laws which give educational institutions the right to license basic technology to commercial firms that have been technologies that have been developed with the aid of government research grants, as well as to spin out startups that they have partial ownership in, that are based on, that have been the basic technologies which have been funded by government grants. Next. In terms of R&D and funding R&D, you really need to focus on needs-based research. You want to use IP landscape analysis to prevent funding projects that reinvent the wheel. A lot of R&D funding, whether it's on the government level or the private level, tends to basically simply reinvent the wheel, and that cuts down on your general R&D efficiency. So, you know, that's all I want to cover in the presentation so far. Be glad to answer any questions, to go into any of these areas in more depth.
So, so that's basically what we're presenting. We're also, you know, we have some, you know, more thoughts we have about different ways to address some of these issues. So, for example, we have a concept we call a studio concept, which is sort of a, if an accelerator focuses on kind of startups as the starting point, foundries focus on individuals as a starting point, and accelerators focus on existing businesses and trying to scale them up. The studio concept focuses on taking these big picture sets of opportunities across multiple ecosystems and trying to develop an opportunity vision or a product vision, and then create a kind of organizational framework to start businesses or to start initiatives or to connect enterprise level companies to small companies in order to kind of create, you know, we call it the stone soup methodology, or the stone soup concept is like, you know, you kind of bring in a lot of different concepts. You know, I think maybe in parts of Europe it's called the axe soup. You know, it's sort of, you bring in lots of different elements, you kind of create a pot that can cook those together, and then spin out or start up or do a joint venture and so forth. Right now, it's hard for a small startup by itself to take advantage of all these different layers, all these different resources, connect with all the right partners. It's really hard for a startup to take advantage of opportunities like AI plus robotics with healthcare because of the complexities of the different ecosystems involved, because of the complexities of different layers of partnerships needed. So we're looking to see if we can create a concept where it supports that kind of more broader, you know, different set of requirements for creating opportunities or developing opportunities. So so anyway, that we should, you know, definitely open up to general questions. Kristiyan, you started with the you know, incentives question, but I know you had other ones as well.
Yep. Yeah, and we've had two of your members who have, without a doubt, interesting perspectives to share on the robotics ecosystem and AI ecosystem, meaning John and Luke, who have been pretty silent up to now. So, Paul, if you can hear me, right? Can you discuss in your views what are the general building blocks of an AI robotics ecosystem, and where is the robotics sector going, in your opinion, in 2021?
Yeah, of course. So in terms of just kind of the general sculpture or sculpting of an AI and robotics ecosystem, I think that, you know, there are a few different necessary components. When you talk about AI, you've got to really look at the concepts or the categories of like computing ability or computing power, and then the data behind that, because without either one, AI is useless. And that's really where a lot of the current market limitations and current technological limitations exist, is with the amount of data and the purity of that data, because you know, garbage in, you know, kind of garbage out type of approach makes AI inherently useless, right? So, and then, you know, you need, as you collect data and as you build a data ecosystem, you need the ability to really kind of compound that in terms of computing ability, right? Because without the appropriate computing power behind this, right, without a scalable computing strategy, then you run into security issues as well, which leads to things like breaches and privacy hacks and so forth. So, you know, and then the second part of the second part of the AI, you know, kind of robotics universe, so to speak, is the hardware aspect, right? AI is, you know, there's two kind of different, you know, there's kind of two different worlds when it comes to AI, right? And one of those worlds is SaaS-based applications. The other part of that world is the hardware, right? The chips the AI is actually built on, the algorithms that makes AI work, you know, built on chips, whether it be in your phone or your computer or whatever, you know, organizations have to now really take a keen eye at, you know, in terms of semiconductor chip technology, they have to really take a keen eye at the hardware aspect of AI, right? And the types of hardware that they're using, and how does hardware, you know, really, you know, kind of over, you know, from a layman's, speaking in layman's terms, speaking at an elementary level, you know, how does AI enhance the hardware itself, right? How does it make the hardware better, more efficient, and reliable, right? So that's kind of the overall ecosystem that I see, and it's growing, it's pervasive in our world. You know, we haven't even touched the tip of the iceberg for what AI can really do for the human race, you know? And so there is a lot of opportunity for innovation there. And in terms of what this world needs, you know, real world impact, solving real world kind of problems, right? Or as you said at the beginning of the call, kind of, you know, our motto is, you know, advancing society forward and improving people's lives and so forth. And technology can do a lot of that. Now, when it comes to robotics, you know, robotics also is poised for, you know, a lot of industry growth, global growth. And there's an education piece around all this as well, in terms of, you know, empowering these technologies to do some good in the world, and to really do what they're capable of, right? And solving problems. So the education piece behind robotics, but also really understanding, you know, how is robotics going to change different industries, even industries that may, you know, outside of, you know, robotics or outside of manufacturing, industries that typically were not, where robotics was not necessarily prevalent. It will be now, like, you know, healthcare, you know, self-driving vehicles, door delivery, right? Drones are a type of robotics, so service delivery. You know, these are industries that typically have not been akin to machines. You know, when you think of robotics, you think of assembly line workers. So now we're kind of getting out of that, right? And so there's different types of roads that robotics is taking us, from soft robotics or invasive robotics, right? The kind of robotics that go in your body that are flexible materials, or you know, porous materials and so forth, to actual manufacturing type robots, right? The do some sort of repetitive action or function that can, either, do a repetitive action or function to replace human movement, right? But not to replace humans, to replace human movement or to subsidize or support human movement, right? So then you have that, and then you have assisted robots, right? Or what I would call not human movement or replacement, but assisted robots in terms of, for example, helping a person get from point A to point B, right? A robot, instead of using crutches, this robot carries you from point A to point B. So human assisted movement, even things like exoskeletons and so forth. So that's kind of that's the robot ecosystem, and I think that there's a lot of opportunity for. I think that we need, as technologists, as a global population, we need to kind of educate consumers to adopt a curious mindset versus a fear-based mindset. And right now, we have movies like Terminator to I think for that fear-based mindset. But I think that we can get over these myths and these misconceptions about robotics.
Now, one roundtable type of question I do have. We have mentioned how governments incentivize adoption of AI and robotics. It was tax credit, education financing, etc. But we also discussed a lot of private sector applications, obviously door-to-door delivery, services sector, e-commerce, which are all high adopters of AI and robotics. So my question to all of you is, how do we incentivize private sector adoption of AI and robotics?
Is it sector by sector, or is it opportunity area by opportunity area, right? So is there a general incentive, or is there incentives, or here, like we were talking about, some of the areas in healthcare, or some of the areas in delivery, or some of the areas in whatever. So if trying to do it on kind of a global, kind of big global basis may not be as effective as saying we have a studio or a program that focuses on applications in this area, and then you're easier to connect specific potential partners that are within your regional ecosystem that could also connect to others in a global ecosystem. And I think that might have get you easier to what Mitch was saying, to more near-term market possibilities than simply putting a big generic push.
Yeah,
I have a few thoughts. Oh.
Go ahead.
Yeah.
I'm sorry. Go ahead, Aaron. Yeah.
Okay. I have a few thoughts, because what's happening with robotics adoption right now, and I'm very much speaking on the lens of warehousing and manufacturing. Those are the two areas I focus on. The bottleneck is the customers, and I really think that if governments want to incentivize customers, it is a huge cost to set up these systems, and it is a huge risk. If they become reliant on a truck unloader robot and the robot doesn't work, they have to retool their entire system, remove the device, and try to find workers to fill that job again. I would say like some kind of financing or grant program. Instead of beating around the bush and financing the things that don't work, have companies have access to capital to purchase these systems. Call it a 0% loan, call it a grant application. But that's how the VCs are investing in the startups. But the customers are very slow to adopt. For a lot of reasons. It is new technology, and they can't risk the operation of their business on new technology. And so the only companies that are really gaining an advantage right now are the ones who are already large, like Amazon, who have the internal ability to finance the development, take the risk, even build redundant warehouses in order to test these systems in. So yeah, I would love to see some kind of government-backed financing options for robotics that actually works for small to medium companies in order to adopt a system, because the companies aren't going to install a robot system for free. They've done that before. It never ends well. And I think that's the way to really ensure the future.
Yes.
Erin, a question here from my side. Usually, what is the time limit that the VC funds should wait after they invest in a robotics or AI startup in order to see some results? In order to see.
Well, this is actually, yeah, that's dependent. There's a big conversation in VC. So I consult with a lot of startups, robot startups, and write their decks or help them write their decks, because you're looking at the venture math. There are two types of VCs, and it's important to know which type you're talking to. The SaaS-based, where is your near-term revenue? What is your monthly revenue? What's your ARR? What's your CAC? What's your LTV? The SaaS-based VC is what's most common. They're trying to model a robot company the same way they model a mobile app company. Like, where's your customer? I want it right now. And then there's the deep tech VC. And there's actually a debate in VC right now about SaaS math versus deep tech math. And the deep tech is more important for robotics, but a VC's demand for near-term revenue is shooting themselves in the foot. The deep tech requires deep tech research and milestones. And the VCs who are good at that, they're asking for tech milestones. They have some certainty that this deep tech component will impact the bottom line in the future. But that part of the stack is so buried in a product line that they have to judge it on both accounts. However, I've also seen robot companies and sensor companies where they get a SaaS-based VC, ask for near-term revenue, and they spend 95% under Series A on redundant hardware product development, only to realize that after they spent that $20-30 million, the company is still valued on only that deep tech component as an acquisition target, and they really wish they just gave up that near-term revenue dream and just focused on the IP and the development of the deep tech component. And that's what VC is supposed to be. It's supposed to be high-risk investment. So it really depends on knowing what kind of VC you're speaking to, a deep tech-minded person or a SaaS-minded person.
Mitch, you had some thought points?
Yeah, I have a bunch of thoughts. I think just from what Erin was just saying, even deep tech VCs have to be concerned about what the ultimate market potential and what specific application areas are going to be targeted by the entities that they fund.
Mm-hmm.
That's been my experience. And so, there's a tendency, and Erin is right, to go look at the sort of either or, either the SaaS model or the deep tech model. I tend to think there's an ultimate truth in the middle.
Mm-hmm.
Where there's, and historically, if you look at the commercialization of emerging technologies, whether it's in IT-related things or advanced materials or what have you, is that the companies that spend the most attention focusing on a specific customer need and a roadmap on how to get there are much more successful than either the investors in or the companies themselves that say, well, we've got this fantastic new technology, and even if they attract lots of early stage investment, it tends not to go anywhere because of lack of focus.
I can add on to that. The focus is very important. And when I'm investing, especially in a deep tech component, I'm really looking for similarities. Like, I invested in a MEMS company.
Yes.
And we know there's not going to be near-term revenue. However, this MEMS technology, if it will be a lot cheaper than current MEMS technology.
Yeah.
And so the company goes out and makes agreement with large companies that distribute MEMS and have that large company say, if this technology works, it would be significantly cheaper than the current technology on the market, and it would be a huge win.
Yeah.
So I'm really looking for close similarities to how you can benchmark against current deep tech products. Is it a better cost? Is it more efficient? But it does need to be specific, because I've also seen other deep tech companies fail, usually in the radio land, like know what it's about. And what's also fun though is pairing application specific people with deep tech people. And that's where being part of a community is very valuable, where the people who understand the market problems might not understand the deep tech options that are out there. This is very prevalent in Wi-Fi right now. Robots cannot trust Wi-Fi.
Yeah.
They just can't.
Yeah.
And so those people should talk to more radio people.
Yeah. You know, as a quick example, I was involved in a very large project for a very large global consumer electronics company. And one of their major concerns in this project was, why was their nanotech lab not generating any new products?
Mm-hmm.
And the reason was, there were a lot of reasons, but the number one reason was because they were operating it as if nanotech was a commercial thing. They had little connection with the actual application units or divisions or potential applications. They were just generating new nanotech technology without any sort of contact to the market.
And I'll just add one more thing on why it's so important to understand the use case is when designing a chip or a system, and I saw this in LiDAR as well, because I worked on solid state LiDAR for 2 years. The trade-offs in engineering decisions, do I do this or that? Those finely Tetris requirements trade-offs can only significantly impact performance and price for a single application. You have to very much understand the application in order to fine-tune the machine in order to have any value. And those are just engineering trade-offs. It's physics, it's costs. And you can't get around that. And that's where it's just much easier to optimize deep tech if with the application in mind.
A bit on my last question, again, a roundtable type of question. Do you think there will be verticals in 2021 which AI and robotic startups will be particularly successful in disrupting, and which are those verticals?
Luke, you haven't spoken before. You have any ideas?
Sorry, I was stuck on mute there. Could you repeat the question, please?
Yeah, go ahead.
Will there be some verticals which AI and robotic startups will be particularly successful in disrupting in 2021, and which are those verticals?
So I am very curious about healthcare. That was something that Abhishek had spoken about earlier. One of the big hurdles I'm seeing, I guess there's different variations, I think, that we can think about this within. I mean, if we're looking at implants, for instance, or different sorts of sensors, I think those are just kind of, to put it reductionistically, they're new takes on a familiar type of technology in medical devices, right? They're new ways of interacting directly with a patient, whether implanted or whether used inside the OR. Where it starts to get really interesting for me is like Abhishek had talked about when we look at decentralized manufacture, especially when we're looking at decentralized manufacture of potentially drugs or biotherapeutics. It's promising, but it's also problematic. Having spent some time in the med device space myself, one of the big hurdles we've had to contend with is the regulatory piece, working with the FDA, demonstrating safety and efficacy. It's difficult to do that with a controlled process, a controlled manufacturing process that's centralized in one location. The difficulties become, I would think, much increased if you're decentralizing the point of manufacture, if you're in fact productizing the manufacture of these therapies. So I think there's tremendous challenge there, but there's also tremendous potential. And I think when there's an intersection of those two things, the person or the people who can figure it out stand to make a very big impact, and it probably make a lot of money too.
I would add one more. I mean, I think we've got, Aaron has been focusing on the supply chain related, manufacturing and delivery, which I think is huge. We've also talked a lot about the healthcare and medical. The one thing I would add would be kind of what's called Proptech something, basically the built environment. And also what's very next door to it is kind of the new mobility, right? So, and those things kind of work together in terms of, where do we live and work? And how much of that can be assisted or disrupted by robotics or AI technologies, and then how do we get there, basically, which those two things, architecture, urban planning, construction, and so forth. There's a whole area there that I think is really going to be disrupted in a major way. Any other questions or roundtable topics?
It seems that on our side, our hour, so to say, passed by discussing the multiple topics. Obviously, I would like to thank you, John, Paul, Mitch, Phil, Aaron, Luke, Abhishek. Obviously, we had a lot of concepts. Aaron's concept about the glass ceiling, Phil's concept about the IDC prediction, obviously Mitch's concept of the tech with no use case in the reverted 80-20 rule. Obviously, you have Paul's concept of the training of AI researchers, and et cetera, et cetera. So I feel that obviously we did manage to cover just enough for an hour, but obviously you have a lot of topics, so to say, up for grabs. At least that's my feeling. But again, ladies and gentlemen, thank you very much for joining us for this hour and for taking your time to speak with us. And hopefully we'll see you guys in the other events of PARA and our additional education pieces.
One of them will be the virtual robotics incubator in the end of October, where Reciprocity ROI will join as lecturers, and they will share their expertise with educational startups, as I said, from the end of October. Thanks once again to Reciprocity ROI, to our PARA members and fans for joining this video. Like us on Facebook, Instagram, LinkedIn, and expect us with more useful content. Thank you very much. Thank you, ladies and gentlemen.
Thank you, everybody. Audience.
Thanks, everybody.
Thank you.
Thank you.
Thanks.